Hello, good afternoon. My name is Alonso Vázquez. In this video, I'll be showing the solution in FluidSim for exercise number 3, that is the biscuit machine. And in this video, we'll be analyzing the movements of cylinder A, B, and C using FluidSim. So first of all, we gotta visualize that we have a group separation since we can't have the same cylinder, well, the same letter, but with different signs. So that's why we separate as A plus, that is the extension of cylinder A in one group. Then we have A, B, and C. There's no letter repetition. And because of this, we can group these three movements in only one group. So we have the contraction of A, the extension of B, and the extension of C. And finally, in the last group, we have the retraction of C and B. So we have C minus and B minus. So this is the sequence that we gotta follow. Now, this is the cascade method. This is the first one. And well, the general characteristic of the cascade method is that first in this section, we have obviously the emergency button and the manual button that we can activate to run all our system. And in this first part, we only have the activation and the activation of all the system. And in this, we can visualize that we have here group 1, the movement that is A plus, the sensor that detects the movement of A plus, and then we have the passing of the other group, and then all these other group, these three movements, that is um, A minus, B plus, and C plus is all the group 2. And then we have all the other passing to the final group, that is group 3, which we have C minus and B minus. So this is the cascade method that it goes like going obviously in like in a cascade way. So we're gonna see how this works. Remember that we must accomplish this sequence. So we going to analyze this. In this case, we don't have any diagram, but with the only sequence we have, we can visualize correctly the expected movements. So in this case, we have first the extension of A. So we expect that A extends and contracts, then B and C extends, and then C and B contracts. So let's see if this work correctly. So we have A, B, C, C, and B, and it repeats the cycle. So this is the simulation of the cascade method, and we can see that it's working correctly. And well, finally, we are going to analyze this final exercise. Well, that is actually the same exercise, but with other method. We have now the step-by-step method. And well, the group separation is the same. So A plus in one group, A minus, B plus, and C plus in the second group, and in the third group, we have C minus and B minus. So the functioning is going to be the same. All the sequence is going to be the same. But in this case, well, the main difference in the step-by-step method is that we have first all the activations and deactivations of all our groups. Now, if you notice here, we had in the cascade method, we have the activation and the movements and the sensor of group 1, then the activation of group 2, and all the movements that group 2 does, and the activation of group 3, and all the movements that it does. So in this case, in the step-by-step method, it's different. We have first all the activations and deactivations, and then in, well, like in going as it says, step by step, we're going to make all the movements. So we have all the activations and all the movements. So that's the main difference between the cascade method and the step-by-step method. Now it should work correctly, like it should work exactly the same and correctly. So now we're gonna see if that is true. So remember we have the sequence. So let's see if even by this method it works correctly. So it has to be AA, well, A plus, A minus, then B, extension of B, extension of C, retraction of C, and retraction of B. So let's see if that works. So A, B, C, B, and it goes again. So we can see that it works actually good. It's working fine. So we can conclude that with both methods, this can be implemented correctly using fluencing. So that is all, and thank you for your attention.